Hi everyone, Ms. Stillman here. This is the homework 4 key. It's very important in this unit to notice when there's a right angle, when there isn't a right angle. It's also important that these questions are now dealing with lengths. So it tells us that OM is 5, LN is 8. What's the length of LM? So I'm going to go back over what I've already labeled here. O to M is 5. Well, what is that thing, OM? That's a radius. I like to do my radii in red radius. It's a memory trick. If you want to use it, feel free. LN is only going to be the part that is sticking outside the triangle, LN. Oops, sorry, that doesn't have a pencil point. I just didn't want to use red. So I tried to grab something. I didn't have a Sharpie handy other than the red one. The part sticking outside of the circle is 8, but that meant ON wasn't labeled originally. So I had to think to myself, oh, that's also a radius. That's also 5. Also radius. And that's going to help me find the entire length of L to O. That's 13. What we don't know is LM, that's our X. What we have to realize is this is not any right triangle, it is a right triangle. When a tangent meets the radius, that's the tangent, that point is where the right angle is. And then we have a right triangle, we could do Pythagorean theorem. Now that part isn't so bad once you know the lengths and plugging the numbers in. The two legs are going to be the side that's the tangent and a radius. And the entire side that passes like this, that's across from the right angle, that's the hypotenuse. So here you go, x squared plus 5 squared equals 13 squared. When you follow through, you're going to get 144 is the x squared. You take the square root, you get x is 12. Or you can write LM is 12. On the next question, focus on the diagram first. We're told that OL is 17. That's the whole entire side over here. And LM is 14, that's over here, and we don't know the radius. So this time the red radius is the X, it's unknown. Well, tangent meets radius, right angle. Pythagorean theorem, here you go. I'm going to start it out a little slower here. X squared plus 14 squared equals 17 squared. That's because the 17 is the hypotenuse, it's across from the right angle. Get x squared plus 196 is equal to 289. Subtract 196 from both sides. Get x squared is 93, and you square root both sides. In this case, they want you to round to the nearest tenth, so you get 9.6. But then there's a follow-up question. What's ln? Well, let's go back to our diagram. The x was the 9.6. The ln is this part sticking out of the circle. Well, we need to know the part in the circle. That's another radius. That's also 9.6. Do the 17 the whole minus that radius of 9.6, you get 7.4. On the next question, it's very similar to the one above, but it's two tangents meeting at point Q. That line in the middle, almost like as if this was a duck and that's the middle of its mouth. It's like the beak of the duck. That part is always going to be the hypotenuse. So that 30 is the hypotenuse. 20 is a leg. X is a leg. The right angle is at either tangent. So you could look at P as the right angle or look at R as the right angle. Pythagorean theorem again. X squared plus 20 squared equals 30 squared. Look at that 400, look at the 900. Subtract 400 from both sides, you get x squared is equal to 500, and you want to square root both sides. Because they want simplest radical form, we have to think of what perfect square goes into 500. The double zeros are a nice clue to think of 100. 100 goes into 500. 500 divided by 100 is 5. So 100 is the perfect square, 5 is the non-perfect square. The square root of 100 is 10. 10 square root of 5. That's the answer for part A. What is the measure of the radius in simplest radical form? Part B is RQ. Well, that's just a duplicate. The tangents are equal. We learned that, looked like a party hat in some of the lessons. Those two lengths are the same, the 20. Okay, that's page 1 for you. Page 2. Here's that tangent idea again with the party hats. The tangents that meet at the same point are equal. We know in this question the numbers 5, 3, and 4, but they only started on one segment at a time. QM was 5, SN was 3, and LR was 4. So technically those red markings were the only ones you had, and you didn't have these 3 numbers. But if you know the idea that when the tangents meet, those lengths are the same, QM meets MS at M. Those two are the same length. SN, RN, same length, both 3. LR, LQ, they meet at L, same length, they're both 4. And then perimeter is just add up the sides, you get 24. In the next diagram, we're given circle O has a radius of 5 and CE is 2. The diameter AC is perpendicular, think about right angles, to chord BD. What is the length of BD? Okay, so there was a lot going on in this picture even before I wrote markings. Let's take a look. Radius is 5. Now, the original radius you would have looked at would have been the one that had the 5 labeled. But please remember that a radius can go anywhere in the circle. Look, even OA is labeled as 5. That means CEO, so CO is a radius of 5. Look at that note right here. I want to just point out, I'm going to write over it in red. Radius, the radius of 5. That's going to help you because then we have this little piece sticking out that they tell us is 2. That 2 is not as helpful as the 3 will be. The 5 is a whole minus the 2. The leftover amount is 3. And then you have a right triangle with a 5, a 3, and the unknown x. Well, it turns out that this x is what you would notice you're supposed to be using in Pythagorean theorem. But at the very end, you're going to have to find BD. So at the very end, we're going to have to understand that a diagram like this is like x times x, and then the 2 pieces get times like that. It's very similar. Or think about just the fact that a chord is being split by the diameter, or a chord meeting radius. We've seen this diagram a couple of different ways. So when you take a look at the Pythagorean theorem, just focus in on the triangle, even if you're not sure about, the multiple choice over there. Focus in on the triangle. I redrew it over here. 3 squared plus x squared is 5 squared. You're going to find x squared is equal to 16, and you take the square root and get x is 4. You're almost done. That x is 4. That's ED. What about BE, the other side of it? Well, that's also 4. Now add the 4's together, take a look, and you get 8. That's the multiple choice answer. The last question over here is probably a more kind of easier, more directly, you can visualize it right away, this question as compared to this question. So this one's just, oh look, I see a diagram like this. I know I need the radius. I know I need that hypotenuse of a right triangle. Chord ST is 10 inches long, and the distance from the center of the circle to ST is 4 inches. So take a look how, what is the length of the radius? Round to the nearest 10th. So look how that 10 is the entire amount. It's 5 and 5. That's the idea I was trying to get at before with 4 and 4, with this little picture over here. This is a perfect example to illustrate it. The 10 is split into 5 and 5. We know the distance from the center to the chord to ST is 4. They tell us that there. And then you don't know the radius. Plug that into Pythagorean theorem. This time it's not, it's not simplest radical form, and there's no perfect square. Square root of 41 is a decimal. Rounded to the nearest 10th, it's 6.4.